Hello everybody, how are you people? So we are here back again with a very new session of our ongoing series of Strate-JEE, जिसमें हम प्रीवियस ईयर क्वेश्चंस को सॉल्व करते हैं और आपको बहुत ही अमेजिंग वे में बता के जाते हैं कि किस टाइप के क्वेश्चंस आ रहे हैं एंड प्रॉपर एनालिसिस के साथ विद एरर एनालिसिस एंड क्वाइट अ गुड क्वेश्चन। इवन हम आपको ये भी बताते हैं कि उस चैप्टर में जैसे आज का जो डिस्कशन होगा वो इलेक्ट्रोस्टैटिक्स के बारे में होगा, वन ऑफ द वेरी मेजर चैप्टर्स। एंड इस चैप्टर से इफ आई टेल यू पीपल, सो ईयरली यू कैन एक्सपेक्ट 5 or 6 questions from this particular unit because it has involvement of electric charges and fields. It also has involvement of potential and capacitance as well. So काफ़ी बल्कि चैप्टर है एंड बहुत ही ज़्यादा अमेजिंग चैप्टर है। स्टूडेंट्स बहुत ज़्यादा प्रॉब्लम फेस करते हैं इस चैप्टर में, इस यूनिट में, एंटायरली इलेक्ट्रोस्टैट्स में। सो हम वो सारी चीज़ों के बारे में डिस्कस करेंगे बहुत ही जल्द। बट फॉर द टाइम बीइंग आप जितने भी लोग प्रेजेंट हो फटाफट चैट बॉक्स में मुझे बताओ एंड जल्दी अपने फॉर द नेक्स्ट 1 hour आई वॉन्ट ऑल योर डिस्ट्रैक्शंस एंड डिस्टर्बेंस टू बी साइडलाइंड। आई वॉन्ट योर एंटायर फोकस towards the screen. इस next 1 hour में we'll be just looking into some very popular questions and the questions which actually have troubled the students in the past years. So this entire series is actually for you people, for the people who are actually dedicatedly preparing for JEE. So आप ये सीरीज देखो। हमने प्रीवियसली भी 11th के सारे चैप्टर्स के इंडिविजुअल सेशंस क्रिएट किए हैं। सो डू वॉच देम गाइज। आपको फिजिक्स के, केमिस्ट्री के, मैथ्स के मिल जाएंगे विद द नेम ऑफ Strate-JEE. Okay, and if I talk about today's session, so today's session will be on electrostats. Now let me give you a good glimpse about Strate-JEE sessions. So हम इसमें we have actually designed this particular series to help you guys get aware about the type and variety of questions which are actually being asked in the present times. मतलब there are always times, right? If I talk about my time, so जो questions उस time पूछे जाते थे and जो questions आज पूछे जाते हैं, they are different. And a person actually needs to get in with the style of questions which are actually being asked, ताकि प्रिपरेशन भी उस लेवल और उस हिसाब से हो सके। सो दीज सेशंस आर ऑब्वियसली डिजाइंड इन सच अ मैनर ओनली जिसमें वील बी गिविंग यू अ very good idea about the type of questions which are being asked. साथ ही साथ what can be the best approach, a time saving approach, and then there are tips, there are obviously tricks as well. And the best thing is that people over here, whatever faculty is actually teaching you, they will definitely tell you about the error quotient, error analysis, which is very important, that in which type of question which all type of errors can be done and what all errors have been done by the students in the past years. So इन सब के बारे में बहुत ही बढ़िया तरीके से डिस्कशन होता है गाइस। तो जिन लोगों ने सेशन सब्सक्राइब नहीं किया है, इस चैनल को सब्सक्राइब नहीं किया है, डू सब्सक्राइब इट जिससे आपको रेगुलर अपडेट्स मिलते रहे। बिकॉज इस चैनल पे एक ऑनगोइंग क्रैश कोर्स भी चल रहा है एंड इस क्रैश कोर्स की फैसिलिटीज भी आप अवेल कर सकते हो। साथ ही साथ हमारी टेस्ट सीरीज लॉन्च हो चुकी है। सो उस टेस्ट सीरीज का भी आपको लिंक मिल जाएगा क्रैश कोर्स के सेशंस में, इवन यहाँ पे भी। एंड आपको ऐप के बारे में तो पता ही है, आई विल बी टॉकिंग अबाउट द ऐप बाय द एंड एंड द क्लोजर ऑफ दिस वीडियो। बट फॉर द टाइम बीइंग व्हाट आई वांट फ्रॉम यू इज दैट फर्स्ट फोकस ऑन दिस सेशन। इस सेशन में आप बहुत अच्छे से देखो एंड यू विल गोइंग टू लव दिस सेशन। यू विल डेफिनेटली हैव सो मेनी टेक अवे एलिमेंट्स फ्रॉम दिस पर्टिकुलर सेशन। ठीक है, नाउ लेट्स टॉक अबाउट माई सेल्फ। सो माई नेम इज आदर्श राय। आई एम अ ग्रेजुएट फ्रॉम NIT Bhopal. I myself have cleared this exam in 2011, and after my college I have been into regular teaching. I just love this subject, physics, and that's the reason I'm in front of you telling you about its concepts. I have a good experience of 6 years and I have made sure that so many students actually get to the dream college. Okay, and if I talk about Extramarks, so Extramarks has a very good repo in the JEE segment, and we have ensured that 1 out of every 7 candidate is selected in it. This is our data for the time being, and we are not boasting about it because we still know that there is a lot of room for improvement, and we are improvising. And I'm sure the next time, the next year, when the results are out, this figure is definitely going to increase. Okay, and if I talk about the content of the application Extramarks, the learning app, then the content is beautiful in itself because it is curated in such a format that it actually caters to the needs of present day questions which are being asked in JEE. Okay, the question the pattern which NTA is using from past so many years to devise the questions. The app has been designed in such a format only, and there are very good and striking features which actually aren't present in the market. Like, one of the features is that you can create your own test, and the benefit of that is that students do realize that here are my weak options, weak areas, here are my strong areas, and I want a question which are from the weak areas so that I can improvise, I can strengthen that up. So there is an option in the app that you can create questions, you can create tests, stressing on those topics only. So that is a very good feature, and that can actually help you in your ongoing preparation. Okay. Now, if I talk about the agenda today, that what all topics we'll be covering in today's session, so the major discussion will be about electric field calculation, then the cases of dipole moment, very hot topic. Then there is electric potential and energy. Then we have capacitor circuits and dielectric slabs. When slabs are inserted in capacitor, what all changes we encounter and how to go ahead with them. Okay, so we have Edu Junction. Hi Edu, how are you? Yaar, it's so long. And then Shinchan. Okay, hi sir. हाय शिंचन, हाउ आर यू एंड वेरी गुड आफ्टरनून टू ऑल ऑफ यू. एंड जितने लोग भी सेशंस देख रहे हैं यार, आपके अगर कोई फ्रेंड्स हो, दोज हु आर इन नीड ऑफ दीज सेशंस, जिनका इलेक्ट्रोस्टैटिक्स वीक हो, जो बोलते हो प्रीवियस ईयर क्वेश्चंस में कि यार हमारे से इलेक्ट्रोस्टैट्स नहीं हो पाता, डू गिव देम अ कॉल एंड टेल देम टू अटेंड दिस सेशन. दे आर डेफिनेटली गोइंग टू लव दिस सेशन. ओके, सब इन सब बातों के बाद हम शुरू करते हैं हमारा सेशन. और हमारा फर्स्ट क्वेश्चन है just over here. The first question says is that the electric field at the center of the cube is. Just wait for a second, there is some problem. Okay, so we are back. Now we need to find the electric field. Okay, electric field at the center of the cube over here. Now we have an arrangement like this. It's such a beautiful arrangement. But इस arrangement के साथ एक problem भी है. इस arrangement को देख के बहुत से students ने पहले question देखते ही back off कर दिया. But बहुत ही easy और simple सा question है. अब देखो, मैं इस चीज़ में एक थोड़ा सा improvisation करना और फिर मैं तुमसे आंसर पूछूंगा, and then उस आंसर के बेसिस पे हम आगे का अपना प्रोसेस चालू करेंगे कि हाउ वी आर गोइंग टू फाइंड द इलेक्ट्रिक फील्ड एट द सेंटर. नाउ वी हैव अ क्यूब अरेंज लाइक दिस, राइट, एंड देयर आर प्लस क्यू चार्जेस on all the corners. So there are 8 corners, we have 8 Q charges except one, and the paper, the question was not created कि इसको highlight भी करें. If you can see over here, this charge, now rest all are plus Q charges, but this one is minus Q charge. Now I was just wishing कि यार क्या ये प्लस क्यू हो जाता. अगर ये प्लस क्यू हो जाता तो सेंटर पे इलेक्ट्रिक फील्ड 0 हो जाती. आंसर कितना सिंपल हो जाता, बट इतना सिंपल आंसर क्यों पूछेगा कोई. बट उन्होंने क्या किया, इस प्लस क्यू की जगह माइनस क्यू रख दिया. सो नाउ लेट्स विजुअलाइज कि अगर वहां प्लस क्यू होता तो सेंटर पे इलेक्ट्रिक फील्ड 0 क्यों होती. सेंटर पे इलेक्ट्रिक फील्ड क्यों होती 0. तो आई एम गेटिंग अ फीलिंग कि अगर यहाँ प्लस क्यू होता तो सेंटर पे, सपोज ये प्लस क्यू है, फॉर द टाइमिंग लेट्स से सपोज वो प्लस क्यू है, एंड मैं एकदम बॉडी सेंटर की बात कर रहा हूँ, दिस इज अ क्यूब. तो क्यूब के एकदम सेंट्रल पॉइंट पे इस प्लस क्यू की वजह से इलेक्ट्रिक फील्ड कितनी होगी, इससे ऑब्वियसली दूर जाती हुई होगी, और उसका मैग्नीट्यूड हो जाएगा kq/r², एंड वेयर r कैन बी द डिस्टेंस बिटवीन द कॉर्नर एंड द बॉडी सेंटर. ओके, सो वहां से मैं kq/r² से इलेक्ट्रिक फील्ड इस प्लस क्यू की वजह से निकाल सकता हूँ, राइट. बट हुआ क्या कि आपने प्लस क्यू को निकाल भी दिया एंड प्लस क्यू की जगह एक माइनस क्यू भी रख दिया. सो नाउ व्हाट इज हैपनिंग इज कि पहले जब प्लस क्यू था एंड उसकी जो एक इलेक्ट्रिक फील्ड थी वो यहाँ होने से नेट इलेक्ट्रिक फील्ड 0 हो रही थी. दैट मीन्स ये जितने भी रेस्ट आपको 7 चार्जेस दिख रहे हैं ना, ऑल दीज रेस्ट 7 चार्जेस, इन सब की वजह से जो एक क्यूमुलेटिव इलेक्ट्रिक फील्ड होगी वो ऑब्वियसली उसके ऑपोजिट होगी. दिस विल बी द क्यूमुलेटिव रिजल्ट, इसको मैं CU बोल देता हूँ, एंड दिस वाज द इलेक्ट्रिक फील्ड ड्यू टू द पॉजिटिव चार्ज अगर यहाँ प्लस क्यू होता, एंड ये दोनों मिलकर यहाँ पे सेंटर पे इलेक्ट्रिक फील्ड 0 कर देते हैं. आई एम अगेन रिपीटिंग माई सेल्फ. अगर सपोज यहाँ प्लस क्यू होता, अगर यहाँ प्लस क्यू होता तो उसकी वजह से इलेक्ट्रिक फील्ड उससे दूर जाती हुई होती, E+, मैंने उसको नाम दे दिया, एंड बाकी 7 जो चार्ज हैं प्लस क्यू, उनकी वजह से जो इलेक्ट्रिक फील्ड होती वो ये क्यूमुलेटिव ECU मैंने दे रखी, उनकी वजह से इस डायरेक्शन में होती, एंड देन इन दैट केस ओनली आई कुड हैव क्लेम्ड कि सेंटर पे इलेक्ट्रिक फील्ड 0 है. यही केस बन पाता, राइट? इसके अलावा तो कोई केस बन ही नहीं सकता था। अब व्हाट दे आर डूइंग इज वो प्लस क्यू को रिमूव करके एक माइनस क्यू ला रहे हैं। अब होगा क्या कि सपोज प्लस क्यू को हमने रिमूव कर दिया, अगर हमने प्लस क्यू को रिमूव कर दिया है तो यहाँ पे कोई भी चार्ज नहीं है, तो ये इलेक्ट्रिक फील्ड भी नहीं रहेगी, राइट? मतलब इन बाकी 7 चार्जेस की वजह से जो क्यूमुलेटिव इलेक्ट्रिक फील्ड होगी दैट विल बी टुवर्ड्स, डायरेक्टेड टुवर्ड्स माइनस क्यू, कुछ इस डायरेक्शन में होगी। इफ आई टेल यू अबाउट द डायरेक्शन, देन द डायरेक्शन ऑब्वियसली विल बी टुवर्ड्स दिस बॉडी डायगोनल, राइट? अब हटाने के बाद आपने एक माइनस क्यू चार्ज भी रख दिया है, तो माइनस क्यू चार्ज रखने की वजह से क्या होगा, उसकी वजह से एक और इलेक्ट्रिक फील्ड होगी उसी के ऊपर, एंड मैग्नीट्यूड उसी के बराबर होगा। समझ में आ रहा है? प्लस क्यू की जगह माइनस क्यू रख दिया तो मैग्नीट्यूड तो इलेक्ट्रिक फील्ड का सेम ही रहेगा ना, जो वेक्टर यहाँ बनाया था पहले उसको जस्ट ऑल्टर करके ऑपोजिट डायरेक्शन में कर दो तो मैग्नीट्यूड तो उतना ही रहेगा, बस डायरेक्शन ऑपोजिट हो जाएगा। मतलब ऑल इन ऑल व्हाट वी कैन एक्चुअली ऑब्जर्व फ्रॉम दिस केस इज कि माइनस क्यू प्लस क्यू को माइनस क्यू से रिप्लेस करने से यहाँ पे इलेक्ट्रिक फील्ड अगर मुझे निकालनी है तो दैट इज जस्ट गोइंग टू बी द ट्वाइस ऑफ द इलेक्ट्रिक फील्ड ड्यू टू दिस माइनस क्यू अलोन। मतलब माइनस क्यू की वजह से बॉडी डायगोनल पे जो इलेक्ट्रिक फील्ड आएगी उसका जस्ट ट्वाइस कर दोगे तो आपको नेट इलेक्ट्रिक फील्ड आ जाएगी। वन विल बी बिकॉज ऑफ माइनस क्यू ओनली एंड वन विल बी बिकॉज ऑफ द रेस्ट 7 चार्जेस। एंड नाउ आई सपोज यू ऑल हैव अंडरस्टूड कि बाकी 7 चार्जेस की वजह से हाउ आई केम टू अ कंक्लूजन कि यहाँ पे जो इलेक्ट्रिक फील्ड होगी उसका मैग्नीट्यूड उसके बराबर ही होगा, जस्ट बाय द केस कि यहाँ प्लस क्यू होता तो नेट इलेक्ट्रिक फील्ड 0 हो जाती। सो नाउ विद दिस अंडरस्टैंडिंग व्हाट आई एक्चुअली नीड टू फाइंड इज, मुझे बस क्या करना है, मुझे बस माइनस क्यू की वजह से बॉडी डायगोनल पे इलेक्ट्रिक फील्ड कैलकुलेट करनी है, उसका मैं ट्वाइस कर दूंगा तो मुझे नेट इलेक्ट्रिक फील्ड पता चल जाएगी एंड देयर आई गो, देयर माय आंसर इज। तो मुझे बस यहाँ पे माइनस क्यू की वजह से इलेक्ट्रिक फील्ड बता दो, माइनस क्यू की वजह से यहाँ पे इलेक्ट्रिक फील्ड बता दो, एंड देन if I know the electric field due to minus q charge, I just need to double it up and I'll get the net electric field. So what will be the value of net electric field? It is just going to be twice the electric field at the body diagonal because of this minus q charge. And what will be its magnitude? So let's name it to be kq. So we have a charge minus q, right? So name it to be kq upon r square. Now what is going to be the distance? This distance. What will be this distance? So we have the edge length as a. We have this edge length a. So this thing which you are observing over here, this actually this diagonal, it is known as the body diagonal. Okay, this is known as the body diagonal. And if I talk about a face diagonal, then here we have this as a face diagonal. Okay, so this is a face diagonal. This is a body diagonal. Now I can calculate the value of face diagonal because if this length is a, this length is a, so obviously they will be perpendicular to each other since this is a cube. So this will be root 2a. Now if this is root 2a, so this is going to be making an angle of 90 degree with this side as well. So this root 2a and this a, just use Pythagoras theorem, perpendicular square plus base square. So it will be 2a square plus a square amounts to 3a square whole under root. That means the body diagonal's length is root 3a. So ये distance कितना है, इस plus q से body center का distance कितना हो जाएगा, half करना है, root 3a by 2. That will be the distance between this minus q and the body center. So that means our x is obviously equal to root 3a by 2 whole square, and this is the value of x. Okay. So now I suppose you have just understood, ये net electric field है, इसका बस magnitude निकालना है and इसका magnitude ही electric field हो जाएगी. Can I do that? Yes, surely I can. अब क्या करना है, इसको बस valuate कर दो और फिर देखो आपका आंसर आ जाएगा. So 2 times 1 upon 4 pi epsilon naught q by 3a square by 4. ये आ गया, इस 4 से ये 4 cancel हो जाएगा. Then उसके बाद क्या आंसर आ जाएगा, 2q upon 3 pi a square epsilon naught. This is the net electric field. But if you look closely towards the option, then in the options the electric field has been distributed along x, y and z axis. That means I cap, j cap और k cap. बट यहाँ पे जो मैं नेट इलेक्ट्रिक फील्ड निकाल रहा हूँ वो तो एक एग्जैक्टली मैग्नीट्यूड निकाल रहा हूँ, तो मुझे उसे डिवाइड भी करना पड़ेगा अमॉन्ग द 3 एक्सिस x, y और z के अलोंग. सो उसका अप्रोच क्या रहेगा, तो देखो वापस आते हैं इसी पे. तो हमारी नेट इलेक्ट्रिक फील्ड देखो इस तरीके से आ रही है, बॉडी डायगोनल के ऑपोजिट आ रही है, एंड इफ यू लुक क्लोजली ये एक सिमेट्रिक स्ट्रक्चर है. if this is a symmetric structure, then what I can actually grasp the fact is that the components of this electric field will be equal among all the three axes. Among all the three axes, the components is going to be equal. Ab we have an equal component along x, I have an equal component along y, I have an equal component along z as well. So what I can do is that ex square plus ey square plus ez square, this is going to be equivalent to E net square, right? This is the formulation. This is obviously the formulation. If I have a component along x, y and z, then under root of a square plus ax square plus ay square plus az square is going to be equivalent to a, that is the net amplitude. So this result only I am going to use. So I have this value of E net, and also I know by the case of symmetry that since this entire structure is symmetric, so individual ex, ey and ez will be equal to 0. So what I can do is I can just replace them by only one entity ex square. So this will amount to 3 times ex square is equal to E net, right? So now what is going to be the value of E net? So E net or ex, what is going to be the value of ex? Ex will be equal to जो भी आपका E net आया divided by root 3. So do I have the value of E net? Yes, here it is, 2q upon 3 pi a square epsilon naught just divided by root 3. So if I divide it by root 3, so 2q upon 3 root 3 pi a square epsilon naught. And this is the value of my individual electric fields along x, y and z axis, because this is Ex and all of them are equal, right? Now one more thing, because यहाँ पे भी आपका आंसर आया नहीं है. अभी बताता हूँ आंसर में क्या प्रॉब्लम है. देखो, एक जगह प्लस है, एक जगह माइनस है. अब कौन सा बेस्ट आंसर है? मैग्नीट्यूड तो आपने सही निकाल लिया, दिस इज द मैग्नीट्यूड, या तो ए होगा या सी होगा, बट डायरेक्शन क्या होगा? सो यहाँ पे वापस देखते हैं. अब देखो डायरेक्शन कहाँ की तरफ है? इज द डायरेक्शन टुवर्ड्स positive x, y and z axis, or is the direction opposite to that? Obviously you can see the direction है that is going to be opposite to that. That means जो components आएंगे वो minus x, minus y और minus z के along आएंगे. That means जो final answer आएगा मेरा क्या आएगा? Option number C. ठीक है? So I suppose आप सभी को समझ में आ गया होगा. If you face any difficulty, any problem in this solution, just mention in the chat list. मैं अभी के अभी I'll just repeat it and make you the explanation much more clear. Hi Stuti, how are you? Hi Diksha, very welcome to you. And Dinesh, yes, can you speak in English? Yeah, Dinesh, I'm trying my best to speak in English. Okay, and कुछ चीज़ है जो आपको नहीं समझ में आए because of the language barrier, you can just ask me again. I'll just repeat it up in English as well. Okay, so now let's move ahead with the next question. The next question is also a very beautiful one. So what this question says is, a charge q is distributed over two concentric conducting thin spherical shells of radii r and capital R. Okay, so we have two concentric shells and charge has been distributed on them. Okay, no problem. And if you can look closely, then the total charge is plus q. So plus q has been distributed on both of them. So one of them might be carrying a charge q1, one of them might be carrying a charge q2. Okay. The other condition is if the surface charge density on the two shells are equal. You know what surface charge density is? It is the total charge carried by the shell divided by its total surface area. So the surface charge density on both the spheres are equal. So the charge has been distributed, capital Q has been distributed in such a manner that the surface charge densities are equal. Okay. Then we need to calculate the electric potential at the common center. At this point I need to calculate the electric potential, not a big issue. Let's just first visualize what they are actually saying. Let's just write down the data. So data क्या बोल रहा है? It is just saying कि एक total charge Q है and suppose आपने उस charge को distribute कर दिया. So I am saying कि मैं Q1 charge inner shell पे चला गया and Q2 charge outer shell पे चला गया. ठीक है? Not a big deal, right? So this capital Q charge would have been equal to Q1 plus Q2, right? Very simple case. This is the case which they are saying कि capital charge Q को ही आपने distribute किया दो shells पे. ठीक है? Perfect. Now आपने शेल्स पे डिस्ट्रीब्यूट कर दिया, बट एक और कंडीशन भी सेटिस्फाई हो रही है. एंड व्हाट इज दैट नेक्स्ट कंडीशन? इट सेज दैट द सरफेस चार्ज डेंसिटीज आर इक्वल. दैट मींस इफ दिस इज सेटिस्फाइड, they are also saying कि sigma 1 will be equal to sigma 2. Now what is sigma 1 and sigma 2? It is the surface charge densities of inner and outer circle or inner and outer shells. So what can be the value of sigma 1? So sigma 1 can be replaced by q1 upon 4 pi small r square, right? Yes, definitely. This is the charge carried by the inner shell, and the inner shell's radius is smaller. And if I talk about sigma 2, so sigma 2 will have charge q2 and 4 pi capital R square, right? This is the case which they are saying. उन्होंने डिस्ट्रीब्यूशन इस हिसाब से किया है कि दोनों के ऊपर जो सरफेस चार्ज डेंसिटीज है वो इक्वल हो गई है, ठीक है. सो ये हमने यहाँ नोट डाउन कर लिया, ये हमने आप नोट डाउन कर लिया. अब मुझे ये लग रहा है कि इन दोनों चीजों से I can individually calculate the value of Q1 and Q2 because Q1 and Q2 वो वेरिएबल हैं जो कि मैंने अपनी सहूलियत के लिए डिफाइन किए हैं. They are not given to me. Q1 and Q2 are not given to me. I have myself to just make the situation comfortable to write them down. I have just given Q1 and Q2 value. What is given to me? It is given to me R or capital R की value. So what I'm going to do, I'm going to calculate the value of Q1 in terms of Q2. ओके, with the help of this relation, और Q1 और Q2 को in terms of capital Q के बनाते हैं, ठीक है. तो अब स्टार्ट करते हैं. What I'm going to do, 4 पाई से 4 पाई देखो कैंसिल हो जाएगा. अगर मैं बात करूं तो Q1 को मैं Q2 स्मॉल r स्क्वायर अपॉन कैपिटल R स्क्वायर लिख सकता हूं. यस सर, डेफिनेटली लिख सकता हूं. और इस Q1 को यहाँ पे रख दूंगा. तो देखो कैपिटल Q की वैल्यू Q2 स्मॉल r स्क्वायर अपॉन कैपिटल R स्क्वायर प्लस Q2 हो जाएगी, राइट. क्या किया मैंने कुछ नहीं किया. मैंने बस Q1 को स्मॉल r स्क्वायर अपॉन कैपिटल R स्क्वायर टाइम्स Q2 रखा है और उसको यहाँ पे रख दिया और देखो इक्वेशन आ गई, राइट. परफेक्ट. अब यहाँ से Q2 को कॉमन ले लेते हैं और रीअरेंजमेंट करके Q2 को इन टर्म्स ऑफ कैपिटल Q रख लेंगे. तो Q2 की वैल्यू कितनी आ जाएगी, स्मॉल r स्क्वायर अपॉन कैपिटल R स्क्वायर उधर चला जाएगा, फिर R स्क्वायर इधर जाएगा. सो इट विल टर्न आउट टू बी Q कैपिटल R स्क्वायर अपॉन R स्क्वायर प्लस स्मॉल r स्क्वायर एंड दिस इज द वैल्यू ऑफ Q2. दिस इज द वैल्यू ऑफ Q2. सो हमने Q2 की वैल्यू निकाल ली. अब क्या मैं Q1 की वैल्यू भी निकाल सकता हूँ? शायद बिल्कुल मैं Q1 की भी वैल्यू निकाल सकता हूं. Q1 क्या था? Q1 था Q2 में स्मॉल r स्क्वायर बाय कैपिटल R स्क्वायर मल्टीप्लाई करना है. तो इसमें मैं स्मॉल r स्क्वायर बाय कैपिटल R स्क्वायर मल्टीप्लाई करूंगा तो डिनोमिनेटर और न्यूमरेटर का कैपिटल R स्क्वायर कैंसिल हो जाएगा एंड जो रिमेनिंग बचेगा दैट विल बी Q1 इज इक्वल टू Q स्मॉल r स्क्वायर अपॉन कैपिटल R स्क्वायर प्लस स्मॉल r स्क्वायर एंड दिस इज द वैल्यू ऑफ Q1. So now I have the value of Q1. I also have the value of Q2. Now the case is very simple. मुझे बस सेंटर पे इलेक्ट्रिक पोटेंशियल पता करना है. So do you people know कि अगर एक कंडक्टिंग शेल है which has a charge Q1 and Q2 तो उनकी वजह से सेंटर पे नेट इलेक्ट्रिक पोटेंशियल कितना होगा. देखो पहली बात तो ये कंडक्टिंग है तो इनकी वजह से थोड़ा चार्ज डिस्ट्रीब्यूशन होगा. कैसे डिस्ट्रीब्यूशन होगा, यहाँ Q1 है तो प्लस Q1 इधर रिसाइड करेगा, राइट. उसके बाद इस प्लस Q1 की वजह से यहां पे एक नेगेटिव Q1 इंड्यूस हो जाएगा एंड यहां पे नेगेटिव Q1 होने की वजह से यहां पे प्लस Q1 चला जाएगा, राइट. सो ये चार्ज रीडिस्ट्रीब्यूशन हो जाएगा. क्लियर है? यस, एकदम क्लियर है, एकदम क्लियर है. अब देखो इस चार्ज रीडिस्ट्रीब्यूशन की वजह से इस Q1 की वजह से सेंटर पे आएगा एक इलेक्ट्रिक पोटेंशियल. इस Q1 की वजह से भी आएगा नेगेटिव Q1 की वजह से यहाँ पे इलेक्ट्रिक पोटेंशियल. बट वो नेगेटिव Q1 वाला जो है ना इस प्लस Q1 वाले को कैंसिल कर देगा. मतलब ऑल इन ऑल चीजों को थोड़ा सिंपलर करते हैं. हमें बस इस Q1 की वजह से यहाँ पोटेंशियल निकालना है और बाहर जो Q2 है उसकी वजह से पोटेंशियल निकालना है. यहाँ इनर साइड में जो माइनस Q1 इंड्यूस हुआ है और एक बाहर चार्ज बाहर वाली शेल में जो एक्स्ट्रा Q1 इंड्यूस हुआ है वो दोनों कैंसिल आउट हो जाएंगे. क्योंकि केस ये बिल्कुल भी नहीं है कि आप ये हमें बताओ. They are not asking you to tell them the magnitude of charge which is getting induced on the shells. They are just interested in the potential part. So for the potential part only, what you are going to do, you are just going to calculate the electric potential due to plus Q1 induced on the inner shell and plus Q2 induced on the outer shell. But instead what is happening in reality is there is plus Q1 on inner shell, there is minus Q1 on the inner side of the outer shell, and there is plus Q2 plus Q1 on the outer surface of the outer shell. Okay, so now I suppose with the help of this diagram and this entire case you have very well understood what are the induced charges. Now let's just calculate the value of electric potential. So the electric potential over here it is just Q1 and Q2. As I told you, I just need to focus on Q1 and Q2 and I'll get the entire result. So potential at the center will obviously be equal to it will be equal to kq1 upon what is the distance, it is r. The center is actually located at distance r, the radius is small r, so I'll just write it to be small r, and the other potential due to plus q2 will be equal to kq2 upon capital R, right. Yes sir. Now I individually have the values of q1 and q2, right. I have the values of Q1 and Q2, so I'm just going to replace them by Q1 and Q2. ठीक है, सो हमें क्या करना है, बस Q1 और Q2 की वैल्यू को रिप्लेस करना है. सो Q1 की वैल्यू हमारे पास Q कैपिटल R स्क्वायर अपॉन कैपिटल R स्क्वायर प्लस स्मॉल r स्क्वायर है. Q2 की वैल्यू है, Q1 की वैल्यू भी है, जस्ट रिप्लेस करो, देखो फटाफट आंसर आएगा. सो यहाँ पे क्या आ रहा है कि Q1 की जगह आई प्लेस कैपिटल Q स्मॉल r स्क्वायर अपॉन दिस स्मॉल r एज इट इज कैपिटल R स्क्वायर प्लस स्मॉल r स्क्वायर. ओके फाइन, इसकी जगह रखते Q2 की जगह K कैपिटल Q कैपिटल R स्क्वायर डिवाइडेड बाय कैपिटल R इंटू कैपिटल R स्क्वायर प्लस स्मॉल r स्क्वायर एंड दिस इज द वैल्यू. सो यहाँ पे कुछ कैंसिलेशन हो रहा है, ये स्मॉल r कैंसिल, कैपिटल R कैंसिल. अब देखो इसके बाद रिजल्ट तो बहुत क्लियर दिख रहा है. KQ कैपिटल R स्क्वायर प्लस R स्क्वायर कैपिटल R स्क्वायर प्लस स्मॉल r स्क्वायर, ये चीजें कॉमन आ जाएगी, अंदर बच जाएगा कैपिटल R प्लस स्मॉल r. सो फाइनली जो रिजल्ट आएगा दैट विल बी KQ कैपिटल R प्लस स्मॉल r डिवाइडेड बाय कैपिटल R स्क्वायर प्लस स्मॉल r स्क्वायर. ठीक है, दिस इज द आंसर. चेक कर लेते क्या सही है. यस सर, ये बिल्कुल सही है. नहीं सर, सही है कि नहीं है यार? 1/4 पाई एप्सिलॉन नॉट कहाँ से आ गया? वो के ही तो है, वो के ही तो है. के को ही तो 1/4 पाई एप्सिलॉन नॉट बोलते हैं, राइट और रॉन्ग? ओके, गुड आफ्टरनून अनामिका, वेरी गुड आफ्टरनून. ठीक है, सो दिस इज द आंसर, दिस इज द आंसर. नाउ आई एम गोइंग टू टेल यू इस क्वेश्चन में प्रॉब्लम क्या हुई. इस क्वेश्चन में प्रॉब्लम यही हुई, इस क्वेश्चन में प्रॉब्लम यही हुई, दिस इज बल्की इन इटसेल्फ, this is bulky in itself. I know the entire approach, so that was the reason I was able to finish it, but it was actually bulky because पहले equation लेना, फिर ये satisfy करना, then to find the value of Q1 in terms of capital Q, then to find the value of Q2 in terms of capital Q, then उसके बाद replace करके फिर ये potential लेना, इसके बाद induced charges का भी sum देखना. So it is bulky, it was bulky, and this was the reason students actually started it, but in between they just left it. And when they reached home, they were knowing कि यार this question was so easy, I could have done it, but it was just time. So over here, with the help of these questions, what I can actually tell you about is there will be definitely 2 to 3 questions or even 4 to 5 in physics which are going to be lengthy, which are definitely going to be lengthy. And if you are seriously facing a time crunch, then my personal suggestion will be to just leave them. But sir, how to determine कि हम इस क्वेश्चन को करें या छोड़ दें, whether to go for it or to just leave it? See, no teacher can actually tell you that. It is only you who is going to decide with the first view of the question whether it is going to be lengthy one or the answer can be reached in a quick span of time. It is only you, and how you will develop that skill is you will have to practice as many questions as possible. With the practicing of so many questions, then only you will be able to get that feeling, that inner feeling of yours कि ये क्वेश्चन बाउंसर है, ये क्वेश्चन नॉर्मल है, कि ये क्वेश्चन किस टाइप, किस अप्रोच से सॉल्व होगा, इसमें आंसर आने की कितनी टेंडेंसी है, कि आई एम जस्ट प्लेइंग अ गेम ऑफ क्रिकेट आउट इन द ओपन, देयर आर नो फील्ड्स, नथिंग. सो मतलब इट्स जस्ट लाइक इट इज you only who is going to decide whether you should approach the question or not, and how to develop that skill. This is kind of a soft skill. Okay, ये एक particular kind of soft skill होगी जो आप develop कर पाओगे, but the only way is to practice as many questions as possible, and that too not of only a single topic. That should be varied in amount. Okay, this is particularly if I talk about एक electrostats का question है, बहुत ही static, but हो सकता है इसमें कुछ NLM का भी portion आ जाता. सो आपको ये सारी चीज़ें पता होनी चाहिए बॉस, आपको ये सारी ही चीज़ें पता होनी चाहिए, देन ओनली यू कैन बी डैम श्योर कि हाँ मेरा एग्ज़ाम बहुत क्लियरली जा सकता है. ठीक है, सो लेट्स मूव अहेड विद द नेक्स्ट क्वेश्चन. एंड अगला क्वेश्चन जो है ये है आपका डाइपोल के बारे में, राइट? डिटरमाइन द इलेक्ट्रिक डाइपोल मोमेंट of the system of 3 charges placed on the vertices of an equilateral triangle as shown in figure. And the reason, this is a very simple question, this is actually a very simple question, and the reason I have placed it because so many students solve questions of electric dipole, but they just leave this यार, मतलब I don't know why. distribution of charges, अलग अलग charges की वजह से जो dipole का arrangement होता है, I don't know why they just study dipole of only a twin charge system. So this is the reason I placed it. Now what will be the dipole moment of this? Now dipole moment we have all studied. It is a combination of equal and opposite charges, right? So if there is a plus q, then there should be a minus q. If there is plus 2q, then there should be minus 2q. Now the problem over here is that I have plus q, but I don't have minus q and minus q. I don't have. So I will have to create them. So what I can do is I can just rearrange this minus 2q in the form of two charges of minus q and minus q, right? Just coinciding with each other. So I can just imagine that there are two charges, one minus q and minus q, and both are located at this vertex only. Both of them are located at this vertex, and the cumulative result is minus 2q. So what is going to happen is there will be a dipole from this minus q to this plus q, like this, okay? And there is also going to be a dipole from this minus q till this plus q, and it is going to be like this, right? And I suppose since the lengths are same, the magnitude of charges are same, so the dipole's strength is also going to be same, because the dipole moment of a dipole is the total charge, the magnitude of the charge of which the dipole is comprised of, multiplied by the length of the dipole. So the length is L and the charges is QQ. So that means the individual dipole, if over here it is P, over here it is P, then individually the magnitudes will be Q times L, right? Now, again, so this is, we have just we have just segmented the dipoles. Now we are in a state that we are able to view the dipoles, but we are interested in the net cumulative result of that. So what is going to be the net cumulative result? So as I told you, we have a dipole like this. Let's name it to be P. Here also there is one more dipole. Let's name it to be P only, because since the magnitudes are same. And what I'm going to do, this is an equilateral triangle. If you can see LLL, all the three sides are equal. So I'm just going to draw an angle bisector, perpendicular bisector, or median, whatever you want to say, since all just coincide with each other on an equilateral triangle. So that means if all the angles are going to be 60 degree, then this angle bisector will have this 60 degree bisected, and this entire angle will be equivalent to 30 degree, right? So if this is 30 degree, so I will have a magnitude, I will have a component of P over here as P cos of 30, right? And similarly, there will be a P's component along the vertical direction only as P cos 30. So there are going to be two components of P, right? One component over here of this dipole moment P cos 30, and one of the components will be of this dipole, that will also be P cos 30, because this angle is also 30, right? And there will be horizontal components of both these dipoles, that is going to be P sin 30 and P sin 30. Now, I think you people are very clear that these two dipoles will obviously cancel each other. Yes, they are both in opposite direction and equal in magnitude. So the entire result, the entire dipole moment will obviously be the net cumulative result of these two dipoles only. So P cos 30 plus P cos 30, and that amounts to 2P cos of 30. That is equivalent to 2. What is the magnitude of the dipole? It is equal to 2QL. Sorry, not K, QL. It is equal to 2QL, and cos 30 is root 3 by 2, right? So I have this magnitude as root 3 Q times L, and this is the value of the net dipole moment. So now I suppose you have just understood. Now in the options, if you can see, there's a particular direction, and trust me guys, there will be so many questions when direction is definitely introduced in the final option, just because people cannot visualize that. it's such a bad thing to say that magnitude निकालना बहुत easy है, but to visualize that कि in which direction that dipole is pointing towards, it becomes very tough for students. So in the previous case when I was talking about a cube, in that case also so many students were just confused in the last portion that I have the magnitude in front of me, but what are going to be the components of the electric field along x, y and z axis? So there you have to go for the imagination part. Trust me, this is actually a very big trouble for the students, because what happens is that they have a pen and a paper, and the paper is a two-dimensional object, and what the question is actually asking about is a three-dimensional thing. Okay, so vectors are going to be in 3 dimensions, but you only have a 2-dimensional paper, so it creates trouble for students. They just lack this ability to visualize. So this thing also you need to do much more, because I'll just tell you my secret how I actually developed this skill. That hello Sachin, how are you? And listen to me. So what I did was that I whenever I read the question, I just used to close my eyes and just tried and visualizing that question. I just tried that so many times. Earlier obviously I was visualizing in the wrong way, but slowly and steadily I was finally able to visualize it in a right pattern, and that has obviously helped me. I have always been a student of this mental thing, so there should be mental calculation and so many things should be on your brain level only, and this actually makes you develop that skill. And trust me, this is the time you can work upon that skill. It is definitely going to help you. You can you'll definitely see the difference when you are in your college or you are in your postgrad state, that you can think so much in your mind, and you just don't need a pen and paper. So this visualizing capability is very good, and you should definitely try hands on it. And so this thing only, matlab, in which direction it will be, it should be all in your brains. You obviously cannot draw a vector out of that 2D two-dimensional paper. It's a three-dimensional object, so how can you just draw on a 2D paper? So you will have to visualize. And obviously so many cubes and all these, if in chemistry also, there's a chapter wherein you will have to draw the cubes, those BCC, FCC, lattice structures. So there also you have to visualize things. So visualization is very important, and it should be in your brain. It should always be in your brain. Okay. So now going forward towards the direction part. So obviously it is in the downward direction, and over here it's very simple. It is just opposite to that of the y-axis, right? So here is y-axis, so obviously this direction is going to be minus y, that is minus j cap. So the right answer is obviously option D. We have the magnitude as root 3 QL, and the direction is going to be minus j cap. So now I suppose all have understood. Hi Anil, how are you? Thanks a lot Anil. I hope you are loving these sessions, and do subscribe to this channel because there are so many good offerings from Extramarks for you people only. Now let's start with this question as well. This question was asked in 2019, and what it says is, for changing the capacitance of a given parallel plate capacitor, a dielectric material. I told you the questions of dielectric in a capacitor, they are such a favorite topic of NTA. They definitely ask questions related with this topic every year. So this question was asked in 2019, and it's a very good question as well. So a dielectric material of dielectric constant is used which has the same area as the plates of the capacitor. That means area is same. Okay. The thickness of the dielectric slab is 3 by 4 times D, where D is the separation between the plates of the capacitor plates. Okay. Now the new capacitance C dash in terms of the original capacitance C naught is given by the following relation. So what they're actually saying is that here is a capacitor, and obviously the capacitor is also not a two-dimensional figure. It obviously has a three-dimensional. It is in the form of a plate, right? So it is just this kind of a structure. Okay. So here is one plate, here is another plate. Now in this region, in this plate region, what we have is that the area of the dielectric is same, and only a length of it has been filled by only a length of the entire dielectric. Only a length of the entire capacitor has been filled by the dielectric. Okay. So the area is same. Now let's say this length, they have very well given us to be, okay, they have given the length to be 3 by 4 times D. Now this is obviously not looking like 3 by 4 times D, so I will obviously have to increase it. So let's just increase it to this level. Now this actually looks like 3 by 4th times D, where D is obviously the total separation between the plates. So here is plate 1 and here is the another plate. Okay. Now what they just want from you is calculate the new capacitance. If you are able to calculate the new capacitance, then it is related with the previous capacitance when there wasn't any dielectric placed inside that capacitor. Okay. And what is its value? What is the relation given to us? That the new capacitance C, I need to find the value of C dash in terms of C naught. I need to find that value. Okay. So what is going to be the new capacitance? So the new capacitance obviously will be equal to A epsilon naught. Now let me give you a very quick formula. If you people are not knowing about the formula, now let's say there isn't only one dielectric placed in it. There are so many dielectrics placed on it with the length L1 and their individual dielectric capacities as K1, K2, K3. So I have so many dielectrics placed over here between these two capacitor plates, one of length L1, dielectric constant K1, another of L2 and dielectric constant K2. So what is going to be the net cumulative capacitance? So it is going to be by this approach, that A epsilon naught upon L1 upon K1 plus L2 upon K2 dot 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 L3 upon K3, and it will stretch till Ln upon Kn. Now, the best part over here, so this is the formula. Okay, this is the formula for the effective capacitance when dielectrics have been placed in it. When dielectrics have been placed in it, this is the effective formula. Now over here, they were so kind that they had placed only one dielectric of length 3d by 4. So the remaining region will be also used, but it will have a dielectric strength K equal to 1, right? The dielectric strength of vacuum or of open air is K equal to 1, and it has a dielectric strength is equal to K. So I will just have to place K over here. So let's just quickly use this formula and calculate the value of C dash. So C dash will definitely turn out to be A epsilon naught divided by, what is the length? L1 is 3d by 4. So 3d by 4 times, what is the dielectric constant? It is equal to K plus, what is the remaining length? The remaining length obviously will be d minus 3d by 4. It is equivalent to d by 4. So it will be equal to d by 4 times, and what is its dielectric constant? It is equal to 1. So this is the value of C dash. Now calculate this value. So let's just multiply K over here and K over here. So we have this common denominator 4K, it will go in the numerator, and over here it will be 3D plus D times K. So this is turning out to be A epsilon naught into 4K goes on the numerator. We can also just put D out of the bracket, and it will be 3 plus K. Now if you can look closely, A epsilon naught by D. What is A epsilon naught by D? A epsilon naught by D is the original capacitance when no such dielectric is placed between the plates. If no dielectric is placed between the plates, then the net capacitance will be equal to A epsilon naught by D. So this is your original capacitance, and hence I can say that C dash is equal to C naught 4K divided by 3 plus K, and this is the value of the net capacitance when the dielectric has been placed. So do we have an option? Yes, we have an option, right? Yes, this is the option. I'm absolutely correct. I'm absolutely correct, and this is the correct answer. So I suppose you all have understood this idea that how we got this final answer. Now let's move ahead and talk about another question. So what this question says is, and this question was asked very recently in 2021 only. Okay, so an infinite number of point charge, each carrying 1 microcoulomb charge, are placed along the y-axis at y equals to 1, 2 meter, 4 meter, 8 meter. Now whenever I get this kind of a series, I always have it in the back of my mind, this is going to be a GP series, and that too, if the terms are stretching till infinity, then I will have to find the result. I will have to remember the summation of infinite numbers in a series whose common ratio is always less than 1. Okay, so I'll just try and generate that kind of a series. If it comes, then that's well and good, because I know the formula of sum of infinite series, sum of infinite terms in a series if the common ratio is less than 1. Okay, so let's just find out if we are obviously getting the result or not. Now what the question again says is, they need to find the total force on a 1 coulomb point charge which is placed at the origin. So at the origin there is a charge whose magnitude is 1 coulomb, and we need to find the total force on this 1 coulomb charge because of this entire arrangement of 1 coulomb charge placed at 1 meter, 2 meter, 4 meter, 8 meter, and so on. And also they have given the value, as x into 10 raised to the power 3 meter, and we need to find the value of x close to the nearest integer. Okay, no problem. Let's first just visualize what this case is happening. So over here, let's suppose this is your y-axis. This is obviously your y-axis, and over here we have this as the origin. And on the origin we have a charge equivalent to 1 coulomb, right? We have a charge over here equivalent to 1 coulomb. Now, this is y is equal to 1, this is y is equal to 2, then 4, then 8, and so on and so forth. So all these points, this is y is equal to 8, this is y is equal to 4, this is y is equal to 2, and this is y is equal to 1. Obviously just don't focus on the distance, they are just to give you, this is just a schematic representation. Obviously this is not the actual length, they are not equidistant. There will, the distance of the separation between all these points will be increasing, that's for sure. Now on all these points I have a charge of 1 microcoulomb distributed. Now can you just give me the value of the electric field due to any one of the charges? So let's say suppose I talk about this charge over here, it is 1 microcoulomb. So what will be the magnitude of electric field due to this 1 microcoulomb at the origin? So it is going to be kq by r square, right? We know the expression kq by r square. So kq by r square will be the magnitude because of this 1 microcoulomb charge at the origin. Now that kq is going to be same for all the rest charges, right? Only the difference which we'll encounter will be with the distance, right? So the net electric field will obviously be equal to kq upon r1 square plus kq upon r2 square, because only the distance is changing. The charges are same. The charges are of 1 microcoulomb only. So it is going to be kq1 by r square, kq2 by r2 square, then kq3 by r3 square, and so on. It goes on for forever till infinity, right? It is not going to be q3. It's just going to be kq upon r1 square plus r2 square plus r3 square, and this term continues till infinity. Okay, so I can just make this common element kq out of the bracket and rest of the elements inside the bracket. So I will have over here k times q and 1 upon r1 square plus 1 upon r2 square. That can be written according to whatever values have been given to me. So what are the values? So it will be 1 upon 1 square plus 1 upon 2 square plus 1 upon 4 square plus 1 upon 8 square, and this just goes on. So can you just look over here for any common ratio? Is there a common ratio first of all? So 1 by 2 square by 1 is 1 by 4. 1 by 4 square by 1 by 2 square is also 1 by 4, and even 1 by 8 square by 1 by 4 square is also 1 by 4. That means there is a common ratio 1 by 4. And is that common ratio less than 1? Yes, it is. 1 by 4 is obviously less than 1. So can I use the sum of infinite terms of a GP series? Yes, I can. That is going to be a upon 1 minus r. So this will give me the value of this entire series which I have segmented from this expression. So now I can very well write down the value of E net, and this is going to be equal to kq upon a upon 1 minus r. So what is the value of a? A is 1 upon 1 minus r. R is what? It is 1 by 4. So this entire expression is turning out to be, this will turn out to be 3 by 4. So it will, the 4 will go on the numerator part. So it is going to be 4 by 3. Now what is the value of k? So k is 1 upon 4 pi epsilon. No. I don't have to write this as 1 upon 4 pi epsilon naught, because I want the value in terms of x into 10 raised to the power 3. So I'm going to write the value of exactly k, and this comes out to be 9 into 10 raised to the power 9, right? Now q is what? Q is 1 microcoulomb. So I'll just replace it by 10 raised to the power minus 6 coulomb, and this obviously will be equal to 4 by 3. So this is the value of net electric field. Okay, this is still not the force. I have to calculate the total force. Okay, so what this is turning out to be, so this result 10 raised to the power 9 into 10 raised to the minus 6 will definitely fetch you up with 10 raised to the power 3 value. So we have received this value. Now I just have to calculate the value of x. So this 3 will cancel this 9. So eventually it is turning out to be 12 times 10 raised to the power 3. Now this is the value of electric field. Now what will be the value of force then? So force is equal to Q times E. Now what is the value of Q? This is not the Q of 1 microcoulomb, because this is obviously the Q which was located on the origin. So I have to calculate the force on this charge of 1 coulomb. So I have calculated the electric field because of all the charges which were plotted along the y-axis. Now I have to calculate the value of force on this 1 coulomb of charge. That instead will be equal to Q times E, and Q's value is 1 coulomb into electric field's value is 12 into 10 raised to the power 3 Newton per coulomb. Okay, so this coulomb will get cancelled, and force, it is eventually turning out to be 12 into 10 raised to the power 3 Newton. So now I suppose all of you must be knowing the value of x, and this is turning out to be equivalent to 12. Okay, so all of you, have you got the result? Is there any trouble in it? And if there is any trouble, I'm over here. See here guys, this is not at all good from your end, because there are so many faculties coming for you, and they are just readily just telling you ki ask the doubts. So you should definitely attend the doubts, right? I have seen that people are watching these sessions, but I just want them to watch the sessions on a live streaming, because that time what happens is you can just ask the doubts immediately. And trust me, if you are having the doubts, if you are having any trouble with the explanation part, and you just ask them instantly without keeping that doubt with yourself and planning it to solve it on a later stage, it actually is not advisable. Even I did that, and I felt in the during the last days of my examination that oh, so many things are actually troubling me. I have a doubt over here, I have a doubt over here, this thing I'm not getting straight. And if there is trouble in that state, that suppose I teach you a concept and you obviously are facing a difficulty, so the grasping power, the amount of the amount of the subject or the concept which you will grasp will definitely not be as compared to a person who has entire clarity about the subject. So clarity is very, very important, and this is the reason I actually am motivating you people ki try to attend the live sessions, whether you are appearing over here, whether you want to attend live sessions over here or somewhere else, but do attend the live sessions. Don't go for the recorded versions, because if something is on a live format, then it definitely gives you a very good feel, and obviously the interest level also increases. And the best part is the doubt resolution. So doubts has to be there. There is not a question that doubt cannot occur. Doubt has to be there. There are so many new things for you people, and this is actually all these questions are meant to develop the analytical ability of your mind. So in the development of that analytical ability, it is a must thing that you should be questioning yourself why this is happening or what is the reason behind this, and this is a must thing. Then only your mind will actually work in that scenario. Your mind has to be trained to look for the problems and ask yourself or some knowledgeable person and get to the answers, and then make a resolution for the society. This is what we are meant for, right? So let's just move ahead for the new question, and I suppose you have just understood the clear thing which I wanted you to say. So the next question over here is that in the circuit shown in the figure, the total charge is 750 microcoulomb, okay, and the voltage across capacitor C2 is 20 volts. Nice. Then the charge on capacitor C2 is. So the language of this question actually confused so many students. And what happened with the language of the question is that people actually felt that the total charge is 750 microcoulomb. If total charge is 750 microcoulomb, then they actually got a feeling, उन्हें ये लगा कि ये चार्ज इस पे भी है, इस पे भी है और इस पे भी है, मतलब Q1 plus Q2 plus Q3 is equal to 750 microcoulomb है, जो कि बिल्कुल भी नहीं था. तीनों पे 750 का डिस्ट्रीब्यूशन नहीं है. The total charge is basically the charge which has passed through the battery. That means this 750 microcoulomb will obviously be the charge on this 15 microfarad capacitor and also on these C2 and C3 capacitors. अब यहाँ पे वो basically distribute हुए. Are you getting the point? What happened was the student got confused that 750 microcoulomb is actually equal to Q1 plus Q2 plus Q3. ठीक है? The language was framed in such a sense, and even I definitely suppose the language was framed to confuse the students, but the options were very justifying in nature, because if you just turn this to be Q1, Q2 and Q3, you wouldn't have an answer. You won't have an answer over here in the four options. So you definitely have to go with this fact that the total charge is actually the charge supplied by the battery to this entire circuit. Okay, so the 750 microcoulomb of charge is actually the charge supplied to this 15 microfarad capacitor, and also this only 750 microcoulomb will be distributed between C2 and C3. Okay, so are you getting the point? So what happens now is that another data which they have given is that the voltage across capacitor C2, मतलब C2 के across the potential difference, that is equivalent to 20 volt. तो C2 के across 20 volt है, तो C3 के across भी 20 volt ही होगा. C2 और C3 जो है सेम पॉइंट्स के अक्रॉस ही तो लगे हैं, तो दैट मीन्स दोनों के अक्रॉस पोटेंशियल डिफरेंस सेम होगा. जितना C2 के अक्रॉस होगा उतना ही C3 के अक्रॉस भी होगा. दैट इज इक्वलेंट टू 20 वोल्ट. So what I can do is I can very well now calculate the charge on C3, and if I know the charge on C3, then I can also calculate the value of charge on C2, because the total charge on both C2 and C3 is known to me, and that is equal to 750 microcoulomb. So this is a very simple explanation, but the only fact was, or the only problem was with the language of the question, and language ने बहुत disturb किया students को, and इसी वजह से students गलती करके आए इस क्वेश्चन में. ठीक है, तो देखो जो टोटल जो चार्ज है इस पूरे सर्किट में, दैट इज इक्वल टू हाउ मच? इट इज इक्वल टू 750 माइक्रोकूलम, एंड दिस इज द टोटल चार्ज. नाउ I have the potential difference across this capacitor C3. So what is the potential difference across C3, and on in relation to that, C2 के across 20 volt है तो C3 के across भी 20 volt रहेगा. That means I can very well calculate the value of Q3, right? So Q3 will be equal to its C times V, right? So it will be C3 times the potential across the third capacitor, and this is 8 times 20. This amounts to 160 microcoulomb. So this is Q3. Now if Q is 750 microcoulomb, that means Q1 will also be 750 microcoulomb, and Q2 will be how much? Q2 will be 750 में से 160 reduce कर दो आप. 160 आपने reduce कर दिया तो 590 microcoulomb, and this is the value of Q2. So we have the value of Q1, we have the value of Q2, and we also have the value of Q3. So what we need to find, हमें पता करना था चार्ज C2 पे कितना चार्ज है, मतलब कैपेसिटर C2 पे कितना चार्ज है, and the value is 590 microcoulomb. So are we right? Yes, definitely. So we are right. Okay, so this is going to be the end of this session, and obviously I wanted to discuss one more question, but there's a time crunch. But this is not all. I seriously feel this is not all. This is a very bulky chapter, but I am under some limitations. That is the reason I will have to close this session. But you are under not, and you need to practice as many questions as you can based on electrostatics, and where you want to go, or what is the best platform. So see, I have seen so many platforms, and this is the reason I am recommending you that it's all about the segmentation and the curation of the questions. I can definitely provide you with lakhs of questions of physics, but if they are not segmented and not in line or in tune with what is being asked in the examination, then it is seriously of no use to you. And this is the reason I am telling you, and again stressing that, कि download Extramarks the learning app, because you'll find a very curated and a very up to mark content for JEE as well as NEET also. So you should definitely try this app and practice as many questions as you can, and also test yourself how well you are, how well is your studies going on regarding any chapter. So both these things can be developed or can be understood on a chapter wise frame. Okay, so we have this chapter wise practice papers, practice sessions. We also have tests based on various chapters, and if you're well enough here, I have learned the entire 11th and 12th, and I just want to give full length or cumulative test, then also you can avail this facility. There are so many full length tests, there are so many quick mock tests as well, and the best feature is just create your own test. So any trouble you face, just create your own test, that's all what you more need, and the result will be in front of you. And also the much better version is the final analysis report which you'll get. The final analysis report is definitely going to give you a very good image of yourself, that how well you are, and in which questions you actually went bad, which questions were tough, which questions were easy, and in which questions you actually took more time and that was required, and where you are standing among your peers. So many things you can actually get from that analysis report. Okay, so give a test, you will definitely get the feeling. And also one very important thing, that Extramarks test series is live. You can avail its benefit. Just go on the website and go on the app as well. You'll get the link to subscribe for the test series. Go for it. It is quite good in itself, and it will definitely help you in your ongoing preparation. Okay, so this is going to be the end, but not the end of our series. So the next session of our series will be based on the topic of current electricity. Very beautiful chapter. Just note down the date, 25th April, 3 p.m. sharp. I'll be back again, and again we are going to meet over there discussing previous year questions, very important topics and tricks and whatnot. So this will be all from my end. And the last quote, don't stay at rest, accelerate your preparation, guys, and happy learning from my end. Bye-bye.